Now we will start our main topic, which is machining. So for machining, let's start with a very basic model. So I will go to wireframe and create a box of any dimensions. Okay, let's make it anchor to the center, and it's 100 to layer number 100 cross 100. Right. Now I will extrude it to let's create a circle inside. Of diameter 60, or just make it 30. Okay, not 30, make it 50. Now go to solid, extrude it. Extrude it to 20. Right. Now I will go to isometric. Okay. So for machining, first I will go to this tab machine, and here we have options. So we will start with the mill, and we will cover mill and lathe in this course. We are not going to wire and router. These are some advanced machines. So here there is a list of machines, and it is default. So let's see if it first is mill default mm.cam. So .mastercam mmd. So this machine is basically used for metric, and this is used for inches. Okay, right. So usually we use the default machine, and in case we have any machine, then we will add it here through the library. Okay, so I will go to with default, and now here we will come to toolpaths. Okay, I think option was not selected. Go with default, and here properties. So now before creating stock, one thing that we should check, that here T is checked, so mean tool plane is top plane. So now let's again go to toolpath and stock setup, and now I will create a bounding box. We can specify other type. So here you can see that stock plane is top plane. Okay, so here is a type of bounding box we can create: rectangular, also cylindrical, in which we have to specify one axis, and that axis is surrounded by. So we will discuss. And this is solid mesh. We can select any other solid which we have created in this drawing, or we have imported from other file, and here is we can select external file as stock. So first we will go with these two. We will not cover this one in this video because it will be a bit difficult. So let's first cover rectangular. So go to bounding box and Control A. So all of it is selected. So end selection. So now the recommended so mean fixed stock size with 0 extra stock is 100 120. Now we will make it 110 and 110 and 25. Alright, now we can create a solid of this stock if we click on this solids. So a solid file will be created. So in this case we are not going to create solid, so I will just uncheck it and okay. Okay, so its origin is currently 00 and 22.5. okay, so this value is basically its origin. Now click OK, and now I will go to stock model, stock setting. Yes, now you can see here is the stock. Now suppose if we want that we don't want any stock below this point, so what we will do, we will go to stock setup, and bounding box, and now again we will click on Control A and selection, and now we will make this portion origin. So now I will make it 110 and 110 and 25. Now you can see that if I will change G view, let's change from here to the right, there is no stock on the ground. Okay, so I will go to isometric. Yeah, isometric is fine. So now we have created stock only on the upper side and we don't have any stock at the bottom. Okay, so an extra option which is this auto orientation, which we will normally use, and their face, if we want our stock to be aligned with any face, so we will specify this face here by clicking on this and this. So for now we will go with this one. Okay, done. Okay, stock is updated. Now first of all we will start with the very basic operation, which is contour. So let's just click on contour and see what chains we are going to machine. So contour basically follow a path, a chain, and drill bit is any other tool will be rotating and it will perform cutting operation. So it is basically mostly used for performing outside cut and mostly for outside cut. Okay, so I will just click on this one, and now we have other options. So operation is contour, right. Tool, here we have some libraries from which we can create select tools. So I will select tool library. Now here we have a lot of tools, so we don't know which tool, and this library is mill tools, mill.mm.tooldb. We can create our own library. Okay, so for now we will just use the default tools, and I will apply filter. Go to filter, here is all and none. I will click on none, and from here okay, all is okay, because we don't want any specific material now. So we will use flat end mill. So this is flat end mill 1. So radius type, tool diameter, what we want, let's say equal to 5. Okay, and I will apply filter. See, we have this tool. Okay, now check, what is the tool length, number of, so length is 8, fluid length, and we have length which is 20. So now we will modify this tool, edit tool, and these settings are okay, and cutting length is 8, so we will make cutting length 25. So we'll go to next. I know this tool will not be actually exist, but for now let's just make cutting length will be 25, and next, finish. Right, we have selected the tool. Now let's check what happened. So if I will play this, see, the tool is moving like and performing cutting on this side. If you can see, the tool is inside the material. So now we will just go towards the other parameters which we haven't defined yet. So we have defined tool, now come to cut parameter. first is compensation type, leave it default, and compensation direction is left, so tool is moving in this way. If I select right, now see it is switched. Okay, tip compensation is which point we are using for cut, center or tip. In this case we have flat and mill, so if we select any option, nothing will be affected, so just leave it. And stock to leave on walls, so if I will click 1, see this is the amount of material which we will leave, so I don't want to leave any material. And similarly it on the floor on this side. Now these diameters are okay. Now let's move to depth cuts. So how much cuts we need? If its depth is 25 mm, so it is not possible that we cut all the 25 mm in a one cut, so we need some cuts. So here we define, so maximum roughing step is 2 mm, so let's make it 5 mm. Okay, so finishing cuts, we only want one finishing cut, and in finishing cut what will be step size? It will be 1. Okay, feed rate and spindle speed, these are default. Okay, step, we will not discuss these advanced options and move to breakthrough. So breakthrough is the amount by which material is the length by which material crosses the bottom part of the tool. So in this case if I will click on breakthrough and I will make it 0.01. okay, only a small amount. Now multi-passes, the difference between depth cut and multi-passes is this, that in depth cut we have specified passes for the depths. So now tool is moving at the side, so if the side distance is too much, which cannot be machined at one, so we use multi-passes for that. So I will activate multi-passes. And how much passes we want? I want one roughing pass and one finishing pass. So for roughing spacing is 5, and for finishing spacing is 0.5. okay, so spring passes, if I uncheck this, apply to all finishing passes. Spring passes is used to clear material, so we will not use, and just leave these diameters default. And finishing passes to all depths, and it means that we don't want let's say we have 5 depths, so we don't want finishing pass for each depth, so we will only make it for final depth. Okay, and machine finishes passes after roughing all contour, machine spring passes after roughing all contour. So currently we will not use any of this option. It means that in this case first machine will cut in depth, perform the all depth cutting process, and then at the end will finish it. So we will not currently. And tabs, leave it in linking parameters. Okay, here is one thing that sometimes we use. The top of stock is 25 and depth is 5. So if let's say I don't want to cut the whole portion, so what I will do, I will here specify a depth, and let's say here is a point for which we want to cut. So currently we want to cut at this point and it is 0, so depth is 0. Okay, the next is just leave it and click on OK. Now you can see that multiple passes here. Now it is the first depth cut, second depth cut, third depth cut. Now it will 5. Now it is doing finishing pass. Here you can see it is the finishing pass. Okay, now let's move to the next machining operation, which is drill. So for drilling I will first go to here solids and wireframe and center point. So here, okay, I have to rotate this direction. Now I will create hole at random points, 4 holes. Okay, all of diameter 10. Okay, I'll make this one to diameter 10. And similarly this one also diameter 10, and this one to 10. Okay, now I will extrude these holes. Extrude. Cut body and through all. Okay, and for this center I will extrude this center to create body just 5 mm. And rotate. Okay, fine. We have modified our model, so now we will perform drilling operation. So go to mill, to check drill, click on drill. So before drilling we normally perform operation called let's move it into side, spot drilling. So spot drilling basically creates a small pit for the drill bit, so it will not go anywhere. So okay, now I will click OK, and here I will go to tool, and again I will go to tool library, filter, none, and I will here find and spot drill, stepper mill, okay, radius mill, chamfer. Here if we hover on it, it will give name, thread mill. Where is this point? Bed top drill, high feed mill, thread mill, oval. So here is the spot drill. I'll click on it, and diameter equal to 10. So here we have this, so click OK, and which was the file, yeah, spot. Okay, now the operation is created. Now see, it will not go inside, just up to the small, yeah. Now we will define its parameters. So go to cut parameter, okay, counterbore drill, no need, all segments, no segment, linking parameters. Okay, here depth is 0. Okay, we don't want to select point, so we want to make a spot of, let's say, just 2 mm, or let's 3 mm. Okay, so I will add 3 and tip compensation. Here is the, okay, so uncheck tip compensation. we are not going to create hole, just it's a spot. Okay, so now let's check the toolpath and play it. You can see now the tool is not moving even to the surface. This is because we have made the depth 3, and because, so this is the 0 and 3 is upward, so we have to make it -3. So I will go to linking parameters and make it -3 and enter. Now check this. Yeah, it's only going 3 mm inside. Right. Now we will add another drilling operation, and this time we will select these holes and yeah, okay. This is order, we can change the order, we can top of list, bottom of list. Similarly, there are some orders. Okay, so this is not important. Now tool, which tool we will use? Again, go to select tool library, filter, and this time we will use a drill, spot drill, chamfer. Here is the drill bit. Yeah, this one is drill. Okay, equal to 10. And here we have two. One is, let's check this name, carbide, and another is HSS material. So we are not concerned with the material, so let's use this one because its length is 49 and this one is 71, too long. Okay, so click OK, and now let's check what has been. Okay, see, it's not going inside. So now we will define its parameters, and I will go to cut parameter. So do we want any dwell time? Dwell time is the time during which the material tool just rotates at the bottom for the given time. Let's say 1 second. Okay, and go to holes, linking parameter, and define the depth. So here I will select this. Okay, I will click on depth, and here I will select an edge, depth, and I'll select any of this. Okay, it's -20. And now tip compensation. So we want tool to the move. So let's say it is 0.25. Okay, 0.25 is okay. So 0.25 mm down, this will move. Okay, and now okay, just make it isometric. And now if I rotate it, okay, you can see that it's not turn on dynamic rotation, and yeah, now see the tool is coming a little bit out of the bottom. That is the breakthrough amount which we have seen. Right. Okay, now we will go towards our new operation, facing. So generally we use facing as the first operation, so but no problem. For this we will have to just select this outer chain. So I'll go to 3D here because it only shows wireframe. Now in 3D, yeah, unselect it, and again, yeah, this one, select it and define the tool. Go to filter, and here is face to, and diameter, let's say equal to 10 mm. So we will create here because we don't have. So double click on face mill, cutting diameter, let's make it 20. Secondary diameter, make it 25, and overall length will be 30. Cutting length 5, okay. Chamfer 45 degrees, shoulder length, make it 10. We don't need this one. And upper diameter 12. Next, here is the length, offset, leave it, and just set the cutting speed in surface meter per minute, amount of material. So these are the parameters which are given in the form of table for each material and type of machine. So currently we don't have any specific material or something like this, so just ignore this and finish. Okay, now we go to tool path and simulate. Currently it is performing only operation at the one depth of cut. Okay, now let's define its parameter and add a finishing operation. So go to cut parameter, and here, so okay, across overlap is the amount by which tool moves across the body, and along overlap, which is the amount, which is the distance in which tool moves along the body, which is this one. Okay, and across is this one. So we can specify this distance. So here you can see that it is, let's cancel it and see, this one is along and this one is across. This one is along, and here if I little bit rotate it, so when this tool comes out for this new round, this will be across. So go to parameter, and it is across is 10%, so 10% is just almost, so there, that's why we can see any or next tool path here. So stock to leave on floor, make it 0, and depth cuts, so maximum roughing step is 5 mm, or let's make it 4 mm. Number of finishing cuts, we want only 1, and step finishing will be 1 mm. Okay, leave feed and these default. Linking parameters, depth is 0 at the top. Okay, or we can just define here, see, it is 0. Top of stock is 25. Okay, currently it is performing roughing. Now it is a finishing operation. Okay, let's change across, and across overlap is 10%, so make it 20, so you can notice it. See, when it was 10, no operation, no tool path were here. When I increased it to 20, Now another toolpath, here it is added. Okay, so it is across and along. Okay, so we can drag this operation in the order. So normally facing is the first operation, so let's move facing at the first. Okay, it is in second. Now facing is the first, contour second, drill and drill counter bow. It is a spot drill. Okay, now what we will do is we will use pocket. Here we will use pocket, and for pocket we use this chain. In pocket, see, this kind of toolpath is created in pocket like this. Okay, go to tool and select this flat end mill, this one, and cut parameter. Don't want any stock. Okay, and roughing, step over percentage, step over distance 10, tolerance, and spiral inside. So yeah, this is some of the paths which are, so currently it is using spiral, this one. So if we step over means the distance between these two toolpaths. Normally it is equal to the diameter of the tool. So entry motion, and finishing. So one pass finishing, spacing 2.5. We don't have any spring pass. And start finishing pass at closest entity, finish outer boundary. Okay, we will not use these operations and go to depth cuts. So we want how much maximum roughing step is, let's say 5. One finishing, step 1. Okay, breakthrough, no breakthrough, linking parameters, and depth is, here we have because we selected that chain, so that's why it is considering depth 0, top of stock 25, and click OK. Now if I will see this spiral motion. Okay, for this part the machining is completed. Now I will click on machine group 1 and go to machine and simulate. Now we will check in the real what will be the behavior of the machine. So here, yeah, this one, yeah, it is a big machine. So here we will uncheck this machine and machine housing. Now I will, if we go to view and fit to screen, now we can, now we don't need this upper portion of the tool, so I will just hide it by using tool components. We don't need holder, shank, so just shank. And here we have the tool, all operations, current operation, segment, similarly trace and follow. Trace means the coming toolpath and follow mean which we have done. Okay, and here initial stock, so we don't need initial stock, we don't need fixture, axis, wireframe, stock and tool. Okay, now I will go to view, fit, and here we can reduce the simulation speed, and there is a performance, so it depends on the system. play. Speed is too much, we can't observe anything. Let's make it, yeah. I will go back, pause it, and go to the start of, and now I will play the first facing operation, performing roughing, and now is a finishing operation. Now it is a contour, depth cuts, and it is a finishing. Spot drilling, now the pocket. See, we have done a big mistake. Now I will close it and I will go to pocket plus parameters, and I will go to which tool we have used for pocket. We have to use this flat end mill, and we have used face mill. Okay, again. Okay. Now go to machine, again go to simulate. Now if I here the timeline, it shows operation, the first operation, second, and now I will make it here. Drilling, and now it is doing. Okay, perfect part. Now here is another feature, which is a report in which we can say that, okay, tool in progress, event, and its movement. Okay, we can, if there is any collision in tool, it shows here. Now let's say if we want to save this model, then we have an option to go to simulation and save stock as STL. So I will save it here on the desktop. And now here we have our stock in STL file format. Go to 3D view. So here is our part. So in some cases the machining operation is done with a different machine groups, means in one different sequences. So in that case we save this as STL, and in the next machine group or sequence we use this stock as the initial stock for the new machining operation. So let's do it and go to Mastercam and go to the next operations. So for that, so let's say I want to engrave something here in machining. So what I can do, I will go to wireframe. First let's just hide these toolpaths, and by selecting the only display selected toolpaths. So now we have selected no one. So go to wireframe and go to planes, create from solid face and add this face. Go to solids, not solid, toolpath. Okay, mill, turn off stock, and now go to planes, add plane from solid face and select this face. Okay, make this as WCS empty plane, so also make it G. So now let's say I'll write something here. So what I will do is go to wireframe, letters, and let's say I write Mastercam here. Mastercam. At this point, it is too small. We can change its height to, say, 5. Okay, reselect the base point. Okay, I think it will be perfect. Right, now done. Now I will make it an isometric view. For this, go to toolpath, and we can use engrave operation, but normally contour is easy to use. We will do it using both. First let's do it with contour. So in contour we will go to here, C plane and window. So in this window, okay, escape it. No, first let's just make it which one is this? G. Now go to toolpath and contour, and here go to wireframe and window. In this window I will select this one, and now it is asking for a start point, so this is start point. Now we got our chains. Okay, and for this we will use a toolpath, let's say filter. We can use a spot drill or something like flat end mill. So let's use flat end mill, equal to diameter 0.5 mm. Okay, we have no such tool, so just create it. Flat end mill, cutting diameter 0.5 mm, overall length 5 mm is enough, cutting length 1 mm, and shoulder length 2 mm, shoulder diameter 1 or 0.5 will look better. Shank diameter will just say 1. Okay, it is 0.5. Okay, 0.5. And here we have this straight. First of all, this is tip corner. It is no corner, sharp. This is chamfer. Okay, this is one angle, I mean one distance chamfer, and this is radius, and this is full radius. This is, you can see, radius at the lower corner, and it is a full radius. So here we can make it mean neck diameter, and we will just leave this like this. Next, and finish. Okay, we will use these two. Okay, cut parameter, leave it like this. Depth cut, no depth cut. multipasses, no multipasses, no breakthrough, and linking parameter depth will be, let's say, just -1 mm. Okay, so now isometry, and go to toolpaths. Here we have this. Okay, now I will check on, if I select this operation in simulation, this will be the only operation which will be shown to us. I will fit, and tool is too small. Okay, nothing is. Hide stock. Okay, let's just check all operations. Simulate. And now move this timeline to next operation, drill pocket, go to previous operation. Go to start, and this one is for next operation. Next. Okay, so next operation, if we zoom it, it is not clearly written because some of the chain is not machined. Okay, it is because the tool is large as compared to the letters. So let's just increase the size of the letter, and for that I will go to wireframe. First let's turn off toolpath. Wires. Okay, in wireframe just let's delete this plane. For this first have made and delete this one. Okay, so okay, delete it. Now let's write again. Make height 10 and let's okay, so it is written opposite side. So first we have to create plane, which in this case we go to from solid face or just activate this one. Create later and okay, reselect. Just reduce it to 7 and make it 8. Okay. So now go to toolpath and see this operation is we have to just don't regenerate, we have to, and here click and rechain all. Now I will okay. And now I will click on here are select all operation, select all dirty operation. So dirty operation is selected and regenerate all selected operation. In this case we can regenerate, and this option is best, regenerate all dirty operation. Okay, now go to right. If I click on geometry, okay, alright, go to toolpath group 1 machine and simulate, go to next operation, next, and make it fit, and symmetric fit, and next pocket spot drilling, pocket, and now we have, so make it a little more slow. See M, similarly A, mass, now you can see everything is so neat. The whole E is not written because in this case this area will be so small that okay, right, okay. Now let's say you want to make this these sharp corners slightly chamfer or fillets. So what can you do? You can go to contour, and in contour you will select 3D and select it, and yeah, select this one, and now go to tool. Let's use this engraving tool for this purpose. Okay, and cut parameters, no cut parameters are required. Here we have the option, it is 2D chamfer. If I click on this, yeah, we will use 2D chamfer, but I will show. Okay, other are complete. Well, first is 2D, which follows the straight path, and the center is at the path. In 2D chamfer, it cuts in a way that some of the portion will tool center will be at such position that some of the portion of is cutted by the tool. Okay, so bottom offset is, let's say chamfer width is 0.5 mm, and bottom offset of the tool is we want to use, let's say 0.1 or 0.2. I don't know the exact dimension. If we get an error, we will. Depth, no depth cut, no multipass steps, linking parameter is required. Okay, so depth will be okay. Let's define the top of stock. That is the top of stock 0, and depth will be, let's say, minus. Okay, click on this, and now check this toolbar. I'll reduce its speed, and now let's check it. Okay, see, it is cutting this portion at our given depth. Now the all edges will be chamfered. Okay, let's check it in simulation. Go to machine and simulate. Okay, it is showing only the last operation with the whole stock, so simulate. Go to next operation, next, 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 and next. Feed more slow so we can play. Yeah, perfect. We define the depth, and depth 1 mm and width 0.5 mm. So here we can define. Okay, to prevent this damage, we can define its entry position and other parameters. So I will go to parameter and disable this lead in lead out. Okay, and then if I will check it here, you can see that tool starting from this one. Let's check it in simulation. So go to simulate, and at the end point I think we have selected single operation. Go to tool path, group 1 and simulate. Go to the next. Go to previous operation, and now the previously tool was starting from this point, and now let's see that tool is starting from the corner. Okay, now let's go to parameter to show you one thing. Let's, if we activate lead in and lead out, so here you can see enter exit at midpoint in closed control. So due to this option, that was going to midpoint and that was creating problems. Alright.